Hey everyone. So we are looking at the 15.4 notes today, dealing with segment relationships in circles. This first slide is giving you the different names for all of the different lines that we can get that cross through a circle. So go ahead and copy this slide, and then I'll say a couple things about it. Okay, so this lesson today is getting into us finding the lengths of different lines that cross through a circle. Okay, just to kind of connect this to what we've done in the past. Okay, recently what we've done is we have found the measure of angles and arcs when lines cross through circles. Okay, we're now, for now, done with those angles and arcs, and what we're focused on now are the actual lengths of those lines crossing through the circle. How long are they? Okay, that's what we get into today in this lesson. Okay, there's three different formulas we're going to get into. Okay, the three types of lines we're going to be focusing on are chords, secant lines, and tangent lines. Okay, and I'll let you know what these mean when we get to them. Okay, but the first formula that we're dealing with are dealing with chords crossing in our circle. Okay, and this formula is called the chord product theorem. Okay, so go ahead, take a minute and copy this. Okay, so obviously the chord product theorem is when we have two chords crossing in our circle. Okay, and what we get is this little formula. Okay, this formula, you can see what we're doing is we're multiplying the two parts of one chord, and we're setting that equal to multiplying the two parts of another chord. Okay, and what we're able to do is, find the missing parts of these chords, by solving the equation. Okay, so it's a pretty simple formula. Let's try it out. Okay, go ahead and copy this circle. We'll do this one together. Okay, so what we have here are, again, two chords crisscrossing. Okay, when you guys go to start these problems, first, here's one of the chords, here's the other chord, right? What we're going to be doing is multiplying the two parts of one chord and setting it equal to multiplying the two parts of the other. Okay, so let's start by multiplying the two parts of this chord. Okay, I'm going to be doing 6 times x. Okay, and what that is equal to is us multiplying the two parts of the other chord. Okay, a 9 times 8, okay, or an 8 times 9. You can swap these, it doesn't matter. Okay, but what does matter is that the two parts, the two numbers you're multiplying, are from the same chord. Be careful with getting parts from one chord mixed up with parts from another chord. Okay, but there it is. We have a little equation we can solve now. Pretty simple math. 6 times x is a 6x. 9 times 8 is 72. All right, and just getting rid of 6 by dividing, looks like we get x equals 72 divided by 6, which is 12. Okay, for some of these problems, that's all they'll ask for is find x, all right? And you'll have your answer. On this problem, though, we aren't asked just to find x. We're asked to find the length of segment KI, which is the entire chord. Okay, but it's pretty simple. Now that we know that x is 12, right here, okay, we can find the length of the whole thing just by adding the pieces, right? So segment KI equals 6 plus 12. All right, and adding those together, we get the length of the segment as 18. Okay, so this one asked us to plug back in, but really the point is creating this equation. We can multiply the two parts of one chord equal to multiplying the two parts of another chord. Okay, so with that in mind, I'm going to have you guys go ahead and try this one out. Go ahead and copy it, set up the equation, try to solve it, and then we'll look it over. Okay, so first thing, we have this chord here. We have this chord here. By the way, I always start with the one that has my variable. So I'm going to start with this red one, multiplying its two parts, 3 times x, and setting that equal to multiplying the two parts of the other chord, 6 times 2. Okay, from here, 3 times x is a 3x. 6 times 2 is 12. divide both sides by 3, and we get x equals 4. Okay. Again, sometimes that's your answer. Often they'll just say find x. On this problem, though, we need to go a step further and find segment AB. Okay, so now that we know that x is 4, you could write it over here. You don't have to, but we can find AB by adding those together. So AB is going to equal 4 plus 3. You could write just 7 here. I don't mind if you skip this step, but I'm writing it out just so we're all on the same page. All right, so segment AB equals 7. Okay, so that's the chord product theorem. Pretty straightforward idea. Okay, so we're going to move on to our next theorem, which is called the secant product theorem. Go ahead, take a minute, copy this, and I'll explain it. Okay, so first thing, what is a secant line technically? If I go back to our very first slide here, okay, a secant line is a line that goes through a circle, hitting it at 2 points. Okay, but the key thing is that it goes through the circle and continues to go. It's a line, unlike a chord that is just a segment that touches. Okay, so they're a lot alike, but a secant is a line that goes through. Okay, so that's what it is. Okay, and on this formula, we have 2 of these secant lines. Okay, we have this one right here, and we have this one right here. Okay, so what do we do with these lines? Okay, let's focus on this one right here. Okay, the formula is that we take EA, which is the outer portion of the secant line, and we multiply it times EB, which is the entire line. Okay, and that's the key difference between this formula and the chord product theorem formula. Okay, outer segment times the entire line, which you'll see when we do the entire line, we'll have to add together its parts. Okay, but we'll get to that. Okay, and then we set that equal to doing the same thing with our other secant line. We take EC, the outer segment, and we multiply it times ED, the entire line. Okay, so this one's a little bit more complicated, but once you get it written out, it's still not too bad. So let's try it out. Okay, go ahead and copy this circle. Okay, so just to point out, we have 2 different secant lines. We have this one here, and we have this one here. Again, start with the one that has your variable in it. Okay, when you guys go to start these problems, the first thing you'll always want to do is start with your segment outside the circle. Okay, so the first thing I'm going to do is just write 5. Okay, and we're going to multiply that by the entire line. Okay, be careful. The entire line isn't just x, and it's not just 5. It's adding those together to get the whole thing, x plus 5. Okay, and with the other line, we do the same thing. So first, outer segment, so that's 6. And then we multiply it times the entire line, which is adding together its 2 parts, 6 plus 7. Okay, or 7 plus 6. It doesn't matter how you what order you add them. Okay, so a little bit more complicated, but still now we have something we can solve. Okay, so on the left, we have 5. We can distribute that into the parentheses. Okay, so let's go ahead and do it. 5 times x is 5x. 5 times 5 is 25. Okay, on the right, we can do all of this math. Remember, if you can add the numbers in the parentheses, you want to start with that. I can do a 6 plus 7 and get, I'm typing it just to make sure, 13, yes, and then I can multiply that by 6. 6 times 13 would give me 78. Okay, and then we just have a little 2-step equation. You guys know we can get rid of the 25 by doing the opposite operation. We got 5x equals 78 minus 25 is 53. And then getting rid of the 5 by dividing, I can tell this is going to give me a decimal, which is fine. 53 divided by 5, I get a 10.6. Okay, and just double checking, finding x, is that what we were asked to do? Yep, so we're good. Okay, just like I always recommend, look at your answer in the context of your circle. Does it make sense for this segment to be a 10.6 when this one is 5? Like, yeah, it almost looks like it's about double its length. Okay, so you can find mistakes sometimes that way. All right, so I'm gonna have you guys try out a couple of these problems. Okay, just want to make it clear. This first one is dealing with secant-secant product. The second one is dealing with chord-chord product. Okay, so go ahead, copy those, try them out, and then we'll look them over. Okay, so taking a look at number one. Okay, first thing is I'm going to start with this secant line because it has my variable. Okay, we start with the outer segment, right? So 3. Okay, and then I'm going to multiply that times the entire line, which is adding together its two parts, x plus 3. And then that equals this secant line doing the same idea, the outer segment, 6, times the entire line, 9 plus 6, or 6 plus 9, it doesn't matter. Okay, so from here, we can distribute the 3. 3 times x is 3x. 3 times 3 is 9. On the right, 9 plus 6 is 15. 15 times 6 is 90. Okay, from here, two-step equation. I'm just going to do it in my calculator. I know I'm going to take 90 and subtract 9 from both sides. Okay, that gives me a 3x equals 81. Divide both sides by 3. X equals 27. Okay, which, by the way, both of these problems just in asking us to find x, right? Okay, let's move on to number 2. Okay, first thing to realize, it is different, right? This is chord-chord product theorem. Remember, these are the easier ones. Okay, I want to multiply the two parts of one chord and set it equal to multiplying the two parts of the other. So let's start with this. 3 times x equals 4 times 6. Okay, before we solve this, I just want to point out, sometimes I see people get this mixed up with the secant-secant, and they'll want to do something like this, 3 times x plus 3. You know what I mean? Okay, but that's not what's happening on this. Don't overcomplicate the chord ones. Okay, but 3 times x is a 3x. 4 times 6 is 24. Divide both sides by 3. Looks like x equals 8. Okay, and also, by the way, this one didn't need us to plug back in and find the entire line. You know, if it wanted us, we could add those together, but this, we just wanted x. Okay, so that was, looking at the secant-secant, little review on the chord. Last formula is called tangent-secant product theorem. Okay, go ahead, take a minute and copy this. Okay, first thing, we got a new line called a tangent line. Okay, let me go back to the very first slide. Okay, a tangent line is a line that touches the circle at just a single point. Okay, kind of comparing that to a secant line, which is a line that goes through a circle and touches it at 2 points. Okay, so that's what makes something a tangent line. It hits at just a single point. Okay, and if you guys take a look at this formula, the picture of the circle, okay, our tangent line is this one right here, right? It's touching the circle at just a single point. Okay, here's the formula. We take that tangent line and we square it. Okay, and then the other line is a secant line, all right, and we do the same thing we were doing before. We take the outer segment, we multiply it times the entire line. Okay, so the secant line is the exact same thing. Okay, what I want to just kind of make kind of clear is this formula right here is actually the exact same formula we just used on the secant-secant product theorem. Okay, because with our tangent line, we are taking the outer segment and multiplying it times the entire line. It just so happens to be the same line that we do that to. That's why we square it. Okay, so I just want to make it kind of clear. It is actually the same rule, but when you see a tangent line, you just need to square it. Okay, so let's try it. Okay, go ahead and copy these two circles. We'll try them out. Okay, so first things first, when you go to start these problems, start by squaring your tangent line. Okay, on number 1, here's my tangent line. Okay, so I'm going to start by squaring that, x squared. Yep. And then move on to your secant line. Same thing as we've been doing. The outer segment, 1 times the entire line, 1 plus 3. Okay, so on this problem for now, we're just bringing down the x squared. We'll worry about that in a bit. Okay, but on the right, we can do this math. 1 plus 3 is 4. 4 times 1, 4. Okay, now we can solve for x. If you guys remember, to get rid of squaring, we do the opposite operation. The opposite of squaring is square rooting. Do both sides. Okay, so these are gone. We got x by itself. Over on the right, square root of 4. You just need to type it in, though you might have memorized that the square root of 4 is 2. Okay, little reminder. When we take the square root of a number, we usually get 2 values. The square root of 4 is a positive 2, but it's also a negative 2. Okay, but you guys probably remember the reason why in geometry we often ignore the negative numbers is because it doesn't make any sense for the length of this to be negative 2 feet long, right? So we ignore the negatives and only focus on the positives. Okay, cool. Let's try with number 2. Okay, first thing, my tangent line on this one is 7. Okay, so we're going to start by squaring that. Okay, my secant line, outer segment, 5, times the entire line, x plus 5. Okay, so obviously we got a little bit different equation, okay, because our variable was in a different spot. That's fine. Okay, 7 squared is 49. On the right, we can distribute 5. 5 times x is 5x. 5 times 5 is 25. Yep, and then now we can start solving for x, right? Get rid of 25 by subtracting. 49 minus 25 gives me 24. On the right equals 5x. And then now I can get rid of the 5 by dividing. Looks like this is also going to give me a decimal. Okay, 24 divided by 5 gives me a 4.8. I'm going to flip it around. Okay, cool. All right, we got one more problem to look at. Just looking back on this, we saw when we had our variable on the tangent line, we saw when we had the variable on the inside of the secant line, but what happens if the variable lands on the outside of the secant line? Okay, let's try one more problem out. Okay, go ahead and copy this. Okay, so find x, and I have a little question mark because, we'll see, can we do it? All right. Whether or not I kind of, alluded to this being a little bit different, we can set this up the same way we've been doing it, right? We have our tangent line, so we're going to start by squaring that. So 12 squared. Okay. And then that's equal to our outer segment of our secant line, x, times the entire line, x plus 7. Okay, cool. So let's see how far we can get. 12 squared is 144. On the right, we can distribute our x. Okay, x times x is x squared. X times 7 is a positive 7x. Okay, so this is where things change a little bit. What we have is a quadratic. We have this x squared, okay? And the way that we solve quadratics is a little bit different than the way we solve a typical linear equation. Okay, so let me just kind of show you what we can do. We won't go through this whole process because you'll see where we're headed. Okay, but when you have a quadratic, the first thing you want is you want to get all of your terms to the same side of the equal sign. So I'm going to take this 144 and I'm going to move it over to the right-hand side. Okay, by the way, it doesn't combine with either one of these. That's why I'm putting it over here. Okay, so what happens? These are gone, okay, which leaves me with a 0. right? I need to have something on that left side. On the right side, I'm just going to write these terms in order. X squared plus 7x minus 144. Okay, you guys have probably seen this before in algebra. This is a quadratic equation in standard form. Okay, and what we can do to solve a quadratic equation is we can factor it, and then we're able to solve it from there. Okay, what we're going to be practicing in the lessons coming up is a little review on how to factor quadratics. Okay, those are kind of scary words to some people, okay, but it's really not as bad as it might sound. And it's a good skill because factoring shows up a lot in Algebra 2. So this is a good review. Okay, but for now, we're going to put a pin in it, and that'll be it for today. Thanks, guys.